Okay, let's move on to next two examples. So over here, for this question 3, question 3, I'll use the red marker. So over here, you're given that this is a right angle triangle, EFG. Angle E is 90 degrees. EF is 14.2 meters, 14.2. FG is 19.4 meters. So now the question is, how do you find angle EFG? How do you find this red color angle EFG? So to do that, let's label the triangle first, alright? So always label the hypo first, right? So let's take a look. Which one is hypo? This one is hypo, right? Hypo, right? Because the longer side of a right angle triangle is also the length is opposite the 90-degree angle. Next, I label the opposite. So this is my reference angle, I look opposite it, so this is my opposite. Last but not least, this is my adjacent, ADJ. Okay, adjacent, because this is a line. Let's take a look, double check. Adjacent is a line that touches both the 90-degree and the reference angle. Okay, so now I've already labeled the right angle triangle. Next, I ask myself, critical question, what do I have? What do I have? Let's take a look. What do I have? I have hypo. Put a tick there. I have hypo. What else do I have? I also have adjacent. I have both adjacent and I have hypo. Second critical question, ask yourself, what are you trying to find? I'm trying to find angle. Okay. So third critical question, which Trigo ratio ties them up? Which Trigo ties up adjacent and hypo? Which Trigo ratio ties them up? Let's take a look over here. Is it this one? Is it tangent? No. Tangent is opposite and adjacent. Is it sine? No. Sine is opposite and hypo. You're looking for something that ties up both adjacent and hypo. It must be cosine. It must be this one, right? Because cosine is adjacent over hypo. So now you know you can use cosine to solve for this angle EFG. Okay, so cosine angle EFG. Oh, sorry, missing right here. Cosine angle EFG equals to, so adjacent over hypo. Adjacent is 14.2. What is my hypo? My hypo is 19.4. So 19.4. Therefore, angle EFG equals to, how do you write cosine? So cosine inverse. Right, cosine inverse. So shift cosine, 14.2 over 19.4. Okay, remember, let your calculator do all the work for you. Don't worry, okay? So where's your cosine inverse? There, we'll look at cosine on top. There's a cosine inverse, right? Shift cosine. So shift cosine bracket. So 14.2. So 14.2 over. I'll press divide over here in this case. 19.4. 19.4. Close bracket. Press equal. There you go. The answer is 42.949. So I'll round this off to 3SF. So 42.9 degrees. 1 dp. Okay, so angle is 1 dp. Always remember, angle is 1 dp, length is 3SF. Okay, so over here, cosine, shift cosine of the 14.2 over 19.4, whatever answer you have, round to 1 dp. Right? Okay, I'll move on to example 4. Okay, example 4 is a little bit harder. Okay, but it's doable. We can do this. Okay, so over here you have this quadrilateral. Quadrilateral means it's a four-sided figure, right? Four-sided polygon. So over here, right, you're given that SP is parallel to PQ. How do you know the parallel? Look at this arrowhead, right? The arrowhead tells you they are parallel. So SP is parallel to PQ. You're also given that angle S is 90 degrees. You're given that angle R is also 90 degrees. You're given that PQ is 10 cm, PS is 8 cm, RQ is 12 cm. Wow, looks complicated, right? But trust me, it's something that we can all do, not that difficult. Okay, so first of all, let me try to find PQR. Mark out the angle first. Use a pencil, mark out the angle PQR. This is the angle you're trying to find. How do you find this angle PQR, or simply just angle Q? How do you find this angle? So if you take a look at this, you realize, Mr. So far we've all been working with right angle triangles. However, now we have a quadrilateral. Where's the right angle triangle? Where's the right angle triangle? Don't panic, I'll show you. Okay? Take a ruler, draw a horizontal line across, such that these two lines are parallel. Right? So look at this. Since it's 90 degrees, right? This means this must also be 90 degrees, right? If it's parallel, right? So what does that tell you? Means this length must be equal to this length. Agree? Yeah? It also tells you that if this is 8 cm, this is 12, this whole length RQ is 12 cm, right? So since this is 8 cm, this part here must be 4 cm, right? How do you know? Because RQ is 12 cm. RQ is 12 cm. Let me rewrite it in case it's not clear. RQ just now was 12 cm, right? The whole thing is 12 cm. So the whole thing is 12 cm. So if this is 8 cm, then this part here must be 4 cm, right? Must be 4 cm. So that 4 plus 8 is 12. So if you look carefully now, don't I have a right angle triangle now? Okay, I'll just let this point be T lah. Let's call this point T lah, huh? T. So I know that TQ is 4 cm. So PQ is 10 cm. This part is 90 degree. Don't you have a right angle triangle now? Look at triangle PQT. Right? Triangle PQT. So for triangle PQT, let's make use of triangle PQT. In triangle PQT, we will use it to help us find angle Q. Right? Because if you look carefully, PQT and PQR, the angle is the same. We are still talking about the same angle. So it doesn't matter how you label it, be it PQT or PQR, same angle. Okay, let's take a look at this right angle triangle now. We can use Trigo ratio to help us find this angle. First of all, what must you do? Label the triangle. So if this is the 90 degree, label the hypo first. So this must be the hypo. Next, label the opposite. What's the opposite? If this is my reference angle, this must be my opposite, OPP. So if this is my opposite, this must be the adjacent, right? Because it's a line that touches both the 90 degree and the reference angle. So now I ask myself, which Trigo ratio? How do I use Trigo ratio to find this? Okay, in case some of you are saying, Mr. Too complicated. Okay, can you redraw this diagram? Okay, Mr. will pluck out this diagram and redraw it for you. Okay, I redraw it for you here. Okay, in case some of you cannot see, so this P, this Q, this T. Okay, exactly the same, 90 degree. So this 4 cm, this is 10 cm. So this is my hypo. This is my adjacent. Oh, sorry, this is my opposite. This is my adjacent. Okay, so this is my angle Q that I'm trying to solve. Okay, angle Q. Ask myself, what do I have? What am I trying to find? I have, what do I have? Let me check. I have hypo. What else do I have? I also have adjacent. Right? So I take what I have first. I have hypo, I have adjacent. I don't have opposite, so don't take wrong. Then now, ask yourself, what am I trying to find? I'm trying to find angle. Okay? What do I have? What am I trying to find? Last but not least, which Trigo ratio ties them up? Which Trigo ratio ties up adjacent and hypo? Adjacent and hypo. Isn't it the same one? Adjacent and hypo. So I can use cosine to tie them up, right? So that means cosine angle PQT, right? PQT must be equals to adjacent over hypo. So 4 over 10. So angle PQT or your PQR, which is what you're trying to find, cosine inverse 4 over 10. Okay? So we just punch our calculator. So shift cosine. So we can punch shift cosine 4 over 10. Okay? Or 4 divided by 10 or 4 over 10. Both also can. Close bracket equals. Okay, so I have a string of answers, 66.42182 something something. So because this is a problem, I'm going to solve a problem. I know that I have SR, okay? I know I'm going to try later how to try to find SR. So over here, in case some of you are thinking, what if later I'm going to use this value, this angle? What should I do? So an advice I normally give students is, you write down all 10 digits first, okay? Or write down all the 10 digits first, okay? Then you round it off. So in the event, if you need to pull out this angle PQT later or PQR, when you want to pull out this angle, just punch all the 10 digits. Okay? You can also use your calculator to store it for you. Okay, so in this case it's 66.42182.152. Okay, degrees. Then round off to 1 dp, 66.4 degrees. So 1 dp, 1 dp. Okay, 66.4 degrees and you're done. So you already solved the first one already. Is that okay? Second one, I want to find SR. How do you find SR? Will you be using this angle? You can use, okay? Or you can don't use, up to you, okay? So over here to find SR, part 2 over here. I'll just write it over here, okay? I'll write it over here, part 2. So if you look carefully, SR is the same length as PT, same length, right? So you realize, that means if I find PT, I have already solved for the length of SR. How do I find the length of PT then? If you look at this right angle triangle, right? This is 10, this is 4. Can you find this? Someone will say, Pythagoras theorem. You're absolutely right. You can use Pythagoras theorem here, right? So SR or PT doesn't matter. Square is equals to, this is your PT square, right? This is the same as PT. So I can 10 square minus 4 square. Okay? If some of you cannot visualize it, okay, never mind, means don't rewrite it. I can write it as this is PT, right? Or SR is the same. SR square plus 4 square equals to 10 square. So SR square is equal to 10 square minus 4 square, exactly what I wrote just now. Therefore, SR is equals to square root 10 square minus 4 square. Just punch your calculator. 10 square minus 4 square. So you square root it, remember to square root it. So length is 3SF, okay? So 9.17 cm, 3SF. Okay, you're done. Okay, so over here, I would like to give you an alternative solution. Just in case some of you say, Mr. If I don't want to use Pythagoras theorem to solve this, can I use Trigo ratio? Answer is yes, you can. Okay, let's go back to this triangle. Because you know that to find SR, right, is the same as finding PT. SR is the same as finding PT, right? We go back to this triangle. Look carefully. You can ask yourself the Trigo ratio. You can ask yourself the critical question, what do I have and what am I trying to find? Okay, over here, example, you ask yourself, Mr. What do I have? I have hypo. Okay, you can use as Jason, okay, up to you. I just choose hypo. Okay, what am I trying to find? I'm trying to find opposite. Okay, I'm trying to find opposite. So I have hypo. I'm trying to find opposite. So third critical question, ask yourself which Trigo ratio ties them up. Which Trigo ratio ties opposite and hypo? I have sine, right? Sine ties up opposite and hypo. So I actually can do this. So sine this angle PQT 66.42182. What's the exact angle? Let me see. Shift cosine 4/10. So 66.42182.152. Okay. You can write 10 digits or if not at least 5 digits. At least 5 digits. Okay. Sum of the angle equals to PT over hypo. Hypo is 10. So opposite over hypo. So in this case, PT is equals to 10 times sine 66.42182.152. Punch your calculator. Times 10. You get exactly the same. 9.165 round off to 3SF, 9.17 cm. Since PT is the same as SR, this tells you that, therefore, from here, therefore, SR is equals to 9.17 cm. Exactly the same. Okay, 9.17 cm. Okay, I hope my examples are clear enough to help.